Welcome to the tutorial on general nonlinear equations. In this tutorial we are going to solve 4 Cauchy problems for general nonlinear equations, and we will highlight some of the important and unique features of each of these examples. So, let us move to the first problem. So, let us solve the Cauchy problem for this equation. So, first thing you have to identify what is the capital F which defines this equation. So, that is p square minus 3q square minus z, and next second step is to parameterize the given Cauchy data. Cauchy data given here is ux0 equal to x square for x in R. Therefore, x equal to fs equal to s. This is in the notation that we have used in the proof of the existence and uniqueness theorem. It is helpful to stick to the notation. Okay, done. Now, we need to solve the step 1 is to solve characteristic strip ODEs. F is given like this. So, what is Fp? It is 2p. Fq is minus 6q, and P of p plus Q of q is 2p square minus 6q square, and using the equation recall is p square minus 3q square minus z equal to 0. P, Q and Z should satisfy that equation. So, this equal to 2Z, and the equation does not depend on x, therefore, the derivative with respect to fx is 0. Similarly, derivative with respect to fy is 0, they do not f does not depend on x and y. So, what we have to compute is fz, fz is minus 1, minus 1 into minus p is plus p, similarly minus 1 into minus q is q. So, this is the system of characteristic strips, equation for characteristic strips. Now, we have to solve this characteristic strip ODE with some initial data, but as you know the Cauchy data gives us only initial conditions for x, y, z. We need to find for p and q, and that is what is called finding an initial strip. So, or completion of gamma to an initial strip. Gamma is given by here, and then we need to find PSQ as solutions to this system. Often it is the case that the second equation gives us information more quickly, because first equation generally is a nonlinear function, and second one most of the times, because the nature of the f and g that we choose, one of them is 0. For example, f prime g prime, in this example g prime is 0. Let us see what that means. In this example it is p f prime s is 1 plus q into g prime s is 0. So, I do not write that, equal to h prime s, that is 2s, which means we know now Ps. So, that is P of s equal to 2s. Now, we need to find Qs. Now, I will use this equation. The equation is p square minus 3q square minus z, in the place of z it is hs equal to 0. But now, I have found what is p square, that is 4s square minus 3q square, hs is s square equal to 0. So, that will give us 3q square equal to 3s square, and that will give us q is equal to plus or minus s. Therefore, we have got 2 pairs Ps Qs. Ps of course is always 2s, other one is Qs is s or minus s. So, thus we have 2 initial strips. What are those? S 0 s square, this is FGH part, and then PQ, that is 2s comma s. Second strip is second initial strip as 0 s square 2s minus s. So, what we do is we will solve the Cauchy problem using this initial strip. Using the second one goes similarly, and we will give finally the answer for the second strip, but we will take this as the initial strip. Step 3 is finding a candidate solution, which means solving characteristic strip ODE with the initial strip. I have recalled here what is a chara strip ODE. And this is the initial strip, initial conditions. given by the first initial strip. I have chosen Qx equal to S here. So, we have to identify which equation is easy to solve. For example, the equation where P and Q involve only and P and Q. Therefore, dP by dt equal to P. This I will demonstrate here clearly the solutions, later on I will straight away write the answers. dV by dt equal to P, therefore, the solution looks like it will be a constant times e power t, right. dy by dx equal to y means solution is e power x into constant. But now when t equal to 0, I want the initial condition to be satisfied. So, A must be 2s. Sorry. So, this equal to 2s e power t. Similarly, we have dq by dt equal to q, that will give us that q of Ts equal to s into e power t. So, we know p and q. So, we can substitute these values here for x and y in the equation for x and y. So, therefore, dx by dt equal to 2p, that is 4s e power t, and here dy by dt is minus 6q, that is equal to minus 6s e power t. Now, we can integrate and we get x of Ts is equal to 4s e power t. Okay, integral of this is same plus that constant. It should be such that x of 0s is equal to s. When I put t equal to 0, I get 4s from here. So, I need to subtract 3s from here. So, now this satisfies the initial condition. Similarly, for y, this is minus 6s e power t, integral will be again e power t. So, minus 6s e power t plus constant, but at t equal to 0, I want the initial condition to be 0. Therefore, minus 6s e power t, I add 6s. Now, this satisfies. So, this is xts, this is yts. Okay. Now, we need to find s and t in terms of x and y. Before that, let us also solve dz by dt. To solve dz by dt, we do not need any information because it involves only z. That gives us that zts is equal to e power 2t into constant, and that constant has to be s square. So, therefore, what I need to know to find the solution is t and s, right, in terms of x and y. That is what the theorem says. Solve for t and s from these equations. So, how do we solve that? So, let me recall what is xts, yts. We have okay. From here you can observe that 3x plus 2y equal to 3s. So, that implies s equal to s of xy equal to 3x plus 2y by 3. This is done. Now, what about t? T is equal to t of xy, that is equal to logarithm of 4x plus 2y divided by 4 by 3 into 3x plus 2y. Of course, only when this makes sense. This is how the s and t turn out to be. Now, if I want to find my solution u of xy, what I need to do, our definition of u of xy is z of t of xy comma s of xy. What is our z of ts? Recall, that is s square e power 2t. So, e power 2t is what we want. We have found t here. So, why do not we compute e power 2t from here? Or sometimes it is much easy to compute s e power t, because that is what is there in our equations for x and y. If you notice, this combination comes s e power t, s e power t. So, if you multiply x and y suitably and add and do something, then you can get rid of this. So, you get an expression for s e power t directly, then you can substitute here and get the answer. So, let us do that. So, what we get is s e power t is actually x plus y by 2, x plus y by 2. Okay. So, y by 2 will make it minus 3s e power t plus 3s. When you add 3s gets cancelled, minus 3s e power t, 4s e power t. So, you get s e power t. So, this is what the expression you got. Therefore, u of x y is equal to x plus y by 2 whole square. This is the solution. So, if we chose, so that is what it is done. Now, suppose you chose the other initial strip. So, this I leave it for you to work it out. What is that initial strip? S 0 s square, P s equal to 2 s, Q s is minus s. We get the solution as u x y is equal to x minus y by 2 whole square. So, let us have a remark. First point is that z equal to u of x y. Okay. So, what is that? One is x plus y by 2 whole square, other one is x minus y by 2 whole square. So, z equal to u of x y in both cases contains the datum curve gamma. Okay. That is what? Solution is global with respect to datum curve. Okay. This is true. So, if you actually compute the Jacobian at 0 comma 0, that is actually 0. So, this happens despite that. Okay. That means, even you have one point of singularity, it may happen that you have a global solution. And what is the domain of this solution? Domain of this solution is R2. What better we can expect? So, this is also global with respect to domain. Okay, equation is nonlinear, but still nice things happen for nonlinear equations also. It can happen. Okay. So, with this observation, what I want to say is that tools used may not be applicable, but it does not prevent equations to have or from having global solutions. Okay. Tools, of course, when j 0 equal to 0, you cannot apply your theorem, existence uniqueness theorem you cannot apply, because transversality condition fails. But despite that, we had global solution, means tools may fail us, but something else actually happens, and because tools are only sufficient conditions, is not it? Application of inverse function theorem or implicit function theorem, they guarantee you certain thing can be done. They do not say it cannot be done if you do not satisfy these conditions. So, therefore, nice things can happen. In this example, distinct base characteristics. Distinct base characteristics do not intersect. They do not intersect. So, 3x plus 2y equal to 3s, this is the equation of a family of base characteristic curves. They are all parallel lines. This is in the case of the first initial strip. and in the case of second initial strip it was 3x minus 2y equal to 3s. This is second initial strip. So, they do not intersect. Okay, let us move on to the next problem. This looks slightly more complicated. Yeah. Okay, so what is f here? P square plus q square plus 2 into p minus x into q minus y minus 2z, and the datum curve u x 0 equal to 0. Therefore, this is S, G is 0, H is 0, S in 0 1. So, what is f p? From here it is 2 p for the first term, from here it is 2 p into q minus y, which is 2 into p plus q minus y. What is f q? It is 2 q from here, and from here it is 2 q into 2 into p minus x. Now, there is no p here. Okay. 2 p, that is coming from p square plus 2 into q minus y. Yeah, q minus y. Now, here is 2 q plus 2 into p minus x, that is 2 into p plus q minus x. Now, dz by dt after some simplifications will become, I am not doing the computation, please do it, 2x into q minus y plus 2y into p minus x, and dp by dt will turn out to be 2 into p plus q minus y, 2 into p plus q minus x. Okay. So, this is the characteristic strip of ODEs for characteristic strips. Now, completion of gamma to an initial strip. So, as before, this equation gives us p into f prime s is 1 plus q into g prime is 0 equal to h prime is 0. So, that gives us straight away p of s is 0. So, once p of s is 0, we have to substitute in the equation and get the equation for q x. So, next thing is f of f g h p q equal to 0, we need to solve, but what is that? It is f of small f s is s, g is 0, h is 0, p we just found is 0 and q. Equal to 0. So, we have to substitute these quantities in the equation. What we get is q square, because p is 0, q square plus 2 into minus s into q equal to 0. So, that implies if you take a q common, q minus 2s equal to 0. That implies q of s, it has two solutions, s and 2s. Therefore, what are the initial strips? Two initial strips are possible. So, as we discussed earlier, initial strips have to be smooth functions, otherwise our procedure does not go through, and of course, initial strips are going to be restriction of the strips coming from the equation, right. Therefore, they must be smooth if the solutions are smooth. So, we will not take for example, we could also take q s is equal to s if s is rational and 2s if it is irrational, sorry not s, this is 0. Yeah, we can do this, but we will not do that because those are bad functions, they are not smooth functions. Okay. So, f g h, that is s 0 0, here one more 0 should be there, this is p is also 0. So, comma p for q also 0, this is one strip, another thing is 0 0 f g h, p is 0 and this is 2s. These are the two strips which are possible. So, let us work with this strip. Working with this is similar. So, we will not do this, we will do with this. So, we have to solve the system of equations. Visibly the system is very complicated, right, everything is coupled like anything, right, pqy up here, pqx up here and so on. But if you observe dx by dt is same as dp by dt, okay. That simplifies slightly, right, because dx by dt equal dp by dt. That means d by dt of x minus p is 0, that means x minus p is always constant, that means x and p differ by a constant. So, similarly for y and q, okay. So, we have to make some simplifications. So, first observation is, as I did, x minus p d by dt is 0. So, that gives us pts minus xts. I do not know both of them, but this relation is there, is constant. And what that constant should be? At t equal to 0, what is it? At t equal to 0, p is 0 and x is s. So, this is minus s. So, therefore, that gives us pts equal to xts minus s. Similarly, we need to find about q. So, y minus q d by dt is 0. So, that will give us y minus q is constant, and what that constant should be? Here I am taking q equal to 0. So, it must be 0. So, therefore, I get qts equal to yts. Therefore, the equation for x, we may write it as 2x minus 2s. Okay. So, that is nothing but dx by dt minus 2x equal to 2s, and integrating this, what we get is xts equal to yes, is minus 2s, xts equal to s. So, please do this computations, the integration of this ODE. Similarly, the equation for y dash, okay, let me do on the next page. Okay, equation for y is y dash equal to 2y plus 2s, and integrating this we get yts is equal to s into e power 2t minus 1. So, from these two expressions, what is that expression for x? xts equal to s. This will give us an expression for s, function of xy is actually x, and what about y? Y I do not know, but let me write e power 2t using this s equal to x. So, y by x plus 1. E power 2t is x plus y is x. So, now equation for z, z prime equal to 4z minus 2sy. On integration, what we get is zts is equal to s square by 2 into e power 2t minus 1 whole square. Therefore, u of xy equal to x square by 2 into y by x whole square, that will give us y square by 2. That is a solution, and solution using the other initial strip what was that? S 0 0, P was 0, Q was 2s gives u of x y is equal to y by 2 into 4x minus 3y. So, here both solutions are global with respect to domain, and of course, once it is global with respect to domain, it is also global with respect to datum curve. Nonlinear equation global solutions. So, message is that nonlinear equations does not mean things are always going to be bad. Let us look at this Cauchy problem, ux cube minus uy equal to 0. So, f is p cube minus q, this is s 0 2s root s, that is the initial curve Cauchy data. Now, this is very simple because f depends only on p and q, f p is 3 p square, f q is minus 1, p of p plus q of q is 3 p cube minus q, okay. That is equal to we can keep it as it is for now, okay, and fx is 0, fz is 0. So, these are 0, this is 0. Now, we need to do this extension. So, always concentrate on this, p f prime is 1 plus q into g prime is 0, so do not even write, equal to 2s root s derivative with respect to s. And that you can see is actually 3 root s, 3 root s. Now, what is q? By our equation p cube minus q is 0. That implies that q is equal to p cube, that is 3 root s whole cube. That is 27 s root s. So, what is the initial strip? We have got only one initial strip here. S 0 2s root s, Ps is 3 root s, Qs is 27 s root s. So, we need to solve this system of equations. Now, here p and q are the simplest equations. So, that gives us Pts is a constant and that has to be 3 root s. Similarly, Qts has to be constant, that has to be 27 s root s. And Yts is also easy, y of Ts is minus t plus constant, when t equal to 0 it should be 0, therefore, this is minus t. And we have to now compute x and z. So, dx by dt is 3 p square, that is 3 into 3 root s whole square, that is 27 s. So, therefore, that implies xts is 27 st plus constant. So, when t equal to 0 I want it to be s, therefore, that must be s, 27 st plus s. Now, let us go to dz by dt, that is 3 p cube minus q, actually that is 2 p cube, because p cube minus q we have chosen it to be 0. So, that is actually 2 p cube. So, which is nothing but 2 into 3 root s cube 27 54 s root s. Therefore, z of t s 54 s root s into t, because this is constant, does not depend on t. When t equal to 0, I want it to be 2 s root s. So, add 2 s root s, because this is 0 at t equal to 0. So, that if you take 2 s root s common, 1 plus 27 t, this is what we have. So, next step is to find out t as a function of x y and s as a function of x y. Okay. So, x t s is equal to s into 1 plus 27 t and y t s is equal to minus t. So, that will give us t is equal to t x y, that is very simple, equal to minus y, and s equal to s of x y equal to x by 1 minus 27 y. Okay, obviously y should not be equal to 1 by 27. So, something is going to happen when y is 1 by 27. Therefore, solution to the Cauchy problem is given by u of x y equal to capital Z of t x y comma s x y, and that will be equal to 2 x root x divided by 1 minus 27 y square root. Of course, x should be positive, right, and y should be less than 1 by 27, because the initial data is given on the x axis and y equal to 1 by 27 is here. Solution is not meaningful at y equal to 1 by 27. So, you have to choose either this domain or this domain. We choose this domain because this is where it is in touch with the Cauchy data. We want to solve solution nearby this gamma 2. Now, let us give a comment on base characteristic curves. Base characteristic curves, they are given by this equation, okay, for each s in 0 to 1. We have considered s in 0 to 1. So, for each fixed s, it is a straight line. This straight line is like this. For reference, I have written x axis and y axis, and this is a line y equal to 1 by 27. This point, something is happening. The base characteristic curves are straight line, they always pass through this point 0 comma 1 by 27 lies on them. That means all of them are meeting up at this point. Slopes are 1 by 27 yes, minus 1 by 27 yes. Okay. As you are coming closer, they are becoming steeper and steeper, like that. So, all of them are meeting at this point, and u is not defined at y is equal to 1 by 27. So, this example tells us that intersecting base characteristic curves pose a problem or stop or prevent a solution from being global. That is the problem, global with respect to domain, and solution of course is global with respect to datum curve in this example, though existence and uniqueness theorem asserts local existence near with respect to datum curve, that kind of solution it asserts. We observe in this example that solution is actually global with respect to the datum curve. Solution is actually global with respect to datum curve, but it is not global with respect to the domain because these base characteristics are meeting up. We will also see in examples using Burger's equation in the next lecture that this is indeed one of the main problems even there. And the last Cauchy problem for today is this equation ux plus half uy square equal to 1, and this is the datum curve, and f as usual p plus q square by 2 minus 1. Okay. And once again it does not depend on x and z. So, these are 0, fp is 1, fq is q, p of p plus q of q is p plus q square. Now, this is p into f prime is 0, so it is not there, q into g prime is 1 and that is equal to hs. So, q is determined. Now, use the equation and get the p. P is equal to 1 minus q square by 2 by the equation. That is equal to 1 minus 2s whole square, 4s square by 2, that is 2s square. So, this is p. So, we have got ps and qs, only one initial strip. F is 0, g is s, h is s square, p is 1 minus 2s square and q is 2s. Now, as before, PTS is 1 minus 2s square, it is a constant, QTS is 2s, what else is easy, XTS is easy, it is t plus some constant and that constant has to be 0 because it should satisfy 0 condition. So, XTS is t. Now, what is YTS? YTS is going to be, Q is a constant, right, 2s. So, 2s into t, but at t equal to 0 it should be s. So, it is this, and dz by dt we need to write down slightly, dz by dt is p plus q square, p is 1 minus 2s square, q square is 4s square. So, that is equal to 1 plus 3s square. Therefore, that gives ZTS equal to 1 plus 3s square into t. When t equal to 0, it should be s square. Okay. Oh, sorry, this is not 3, it is 2. 1 plus 2s square. So, this is not 3, it is 2, 1 plus 2s square. Okay. So, t is here, s is here, where is s? T is here, from here we can get for s, this is s into 1 plus 2t. So, what we get is t is equal to t of xy is equal to x and s is equal to s of xy is equal to y by 1 plus 2x. So, when we substitute in the formula for z, the solution we obtain will be uxy, after simplification it is x plus y square by 1 plus 2x. So, once again the solution is global with respect to datum curve, but not global with respect to domain. As we see, formula has a denominator 1 by 1 plus 2x somewhere. So, there is a problem at the point when the denominator is 0. So, it turns out that at that point base characteristics meet up. So, equations for base characteristics is y by s equal to 1 plus 2x. Okay. That implies y is equal to 2sx plus s okay. All of them pass through minus half 0, when s is minus half, y is 0. So, whatever may be the s pass ls goes through this point. So, that is this point minus half comma 0, okay. Is passing through this, maybe undo. Like that. This is for S positive, these are family correspond to positive S's, and for the other one for negative S's it is going to be like that, and so on. Okay. So, all of them pass through this. So, base characters meet up at this point, therefore, we see a trouble in the formula for the solution 1 by 1 plus 2x. So, the solution surface will be singular at this point, and that is clear by the formula. So, if base characteristics meet, we expect troubles. Yeah. So, this completes the tutorial on Cauchy problems for nonlinear equations. Please solve as many problems as you can, and in each of the problem analyze if you can find out some expression for the base characteristic curves and see whether they meet or not meet, etc. Consider all these considerations. Thank you.